Before I give you a live demo and a challenge, let's walk through some theory of traditional SQL injection. In a nutshell, SQL injection lets us manipulate or change SQL queries that are made to a database. For example, if we have a simple SQL statement, our input might change it so that it returns a different result. Here we have select all from messages, where sender equals the username. So in our case, if our username is Jeremy, we have select all from messages where sender equals Jeremy. So this will return all of the messages where Jeremy is the sender. If we change this, if we can inject our own value into the username parameter, we might get something like select all from messages where sender equals Jeremy or sender equals admin. And of course, this will return all of the messages where the sender is Jeremy or the sender is the administrator. Fundamentally, it's really that simple. The situation becomes more complex when we have things like input filtering that we need to bypass. In this case, we can't simply assume our input is being directly appended to the SQL query. Different databases also have slightly different syntaxes, so enumerating the underlying technology is also part of our process. Sometimes a query will trigger an action that is not visible to us, so we're unsure whether it actually worked or not. This is called blind SQL injection. But don't worry, as long as we have solid fundamentals, take the time to understand what we see in practice, we'll be successful. In this module, we're going to look at a few common ways to find and exploit SQL injection. We'll cover fuzzing for SQL injection, triggering error messages, verifying our SQL injection attack, using a union select attack to steal data from other tables. We'll then look at the logic of a common authentication bypass, and then of course we'll also look at NoSQL injection too. I'll see you in the next video.